Hi, everyone. Welcome to the latest installment of our Coffee Talk series. Each of these hour-long information-packed Coffee Talk episodes are curated by the editors and feature insights from independent experts on a wide range of industry topics. Today's Coffee Talk episode, of course, is titled Object Storage for Backup and Disaster Recovery 101. Thank you so much for attending, and also many thanks to Quest for underwriting this episode, because without their support, this series would not be possible. I'm Gladys Lama. I'm the editorial director of Converge 360 here, and I'll be moderating today's episode. But before we get started, just a couple of bits of housekeeping. First, this episode is being recorded so that you can listen to it later. Keep an eye out for an email from us with a link to that recording. It should be coming your way in the next couple of days. Second, we are going to make some time after each of our presentations today to answer your questions. So anytime you have a question, if it occurs to you, just go ahead and pop that into the Q&A box on your console, and we're going to do our best to get to all of them. Or if we can't get to all of them, we'll make sure someone from the team gets back to you afterwards so that they can answer your question directly. Finally, our sponsor Quest has provided some excellent extra resources that can be found on the right-hand side of your screen there, so please be sure to check those out. And as a small thank you to all the attendees who stick with us to the end, we are giving away a $5 gift certificate to Starbucks. So do keep an eye out for that as well. And finally, I would like to welcome our first presenter. He's a regular speaker here with us. His name is Greg Schulz, founder and IT analyst at Server StorageIO. Greg has been both the IT customer and the IT vendor in his experience, as well as a consulting analyst and author of several books, including software-defined data infrastructure essentials. Greg brings a diverse background with real-world perspective across applications, data infrastructures, hardware, software, and clouds. He's also a Microsoft MVP Cloud Data Center Management and a previous 10-time VMware V expert. Greg, I'll give you the floor now. Thanks so much for being here with us.
Great, thanks Gladys, and for that introduction, and hello and welcome everybody to today's Object Storage for Backup and Disaster Recovery 101. Let's get right into it, and let's talk about what's the objective, a little pun intended here, of object storage. And we're gonna look at the big picture, we'll dig into it a little bit, and then the other part of this, we're gonna hear from Graham from Quest about some other aspects about actually using and leveraging object storage. But here's the first thing right off the bat, before we drill into some of the architecture mechanics, is where does object storage fit? We'll get more into what is it and how to use it and some different things like that. But the object storage opportunity, if we look at this diagram here, is that there's three main areas. There's data with known value, high performance, high value. You know, you're going to put that on traditional, different classes, categories of storage, hard drive, solid state, you know, on-prem, cloud, whatever it happens to be. There's that data has no value. In other words, it's transient. You can get rid of it while you're keeping it around. But in between those two knowns, this is where you can have some fun of saying between the known and the unknown are doors. All right, I might be dating myself with that, but between those two areas, that known value and that no value, is the unknown value today, but it's also where there is the most opportunity and need for storage with more flexibility, different cost attributes, different characteristics, and whether that be for archives, for data protection, backup, BCDR, just general bulk storage, data lake, seas of data. It's a very, very big, broad area that is the object storage opportunity. And part of that is because of the cost aspect, the different classes, characteristics. It could be in the cloud, it could be on-prem. It could be suited for a lot of different needs, a lot of different use cases, as well as how you're accessing it. So that's why I wanted to start off with this, is where does it fit? It's in a very, very big area. Certainly there are some overlaps, but what it also means is that there is the wide, wide world of object storage, and our focus today is going to be around backup and disaster recovery. So having done that part to it, having set that big picture view, let's look at things a little differently here. And this is where we need to bring some context and bring some terms into the discussion here. Okay, because when you hear the term object storage, it can mean a lot of different things. For example, if you're coming from the database type world, you might be thinking a database object, a different entity, how things are stored within the database. If you're coming from the programmer, the developer world, you might hear object and you might be thinking, oh, object-oriented programming or something similar with a similar context. And that's why we want to put a little bit of context and some terms around this. And we'll just run some of these in kind of well, in just an order here. So with object storage, you have different attributes. You have different access controls, different securities, ownership, durability, replication, different things like that, as well as metadata, which can be one of its key identifiers, key attributes, is being able to describe the data, add more information about the data beyond simple, when was it modified, when was it created, when was it, what are the access controls, being able to define more things about that data, the application that created it, different information, different tags, different things like that. So there are all these different attributes of how you're going to use it. But one of the areas that where there can be some confusion is that depending on what products you're using, some object storage is in the parlance of having buckets where the objects are stored. But objects can also be referred to as blobs. And here again, we're going to have to do a little context. And in some worlds, the nomenclature is a bucket and an object, which is the bucket is the hierarchy of where the objects are stored or are part of. Not all that different from a directory structure, candidly. But in some parlance, that you're, instead of having a bucket, you have a container, not to be confused with a Docker container. Okay. So you can hear the term object, which can be a blob can be an object. And in this category, the context is that it's an object, it's a storage that's defined as an object, it's storage defined as a blob, not to be confused with a database blob, i.e. Usually large media imaging, but they have some similar characteristics, attributes, but they're different. Likewise, if you hear the term container in the context of object storage, that could be the same thing as a bucket. So for example, on AWS, a bucket is that hierarchy that objects are kept in. And there can be different classes and categories of buckets and objects with different performance attributes, lifespans, things like that. Over in the Microsoft Azure world, instead of calling them objects, they're called blobs. And there's different kinds of blobs, block blobs, page file blobs, append blobs. Then though in the Microsoft Azure world, blobs, i.e. objects, are stored or kept as a part of a container. The container is the equivalency of a bucket. It might be a little confusing, but if you just keep those nomenclatures in place, and that if you hear the term object storage with a container, just have that context. Is it storage that's being used by a Docker or Kubernetes container, or is it referring to the container that's accessing the storage? Just keep that context in mind. It's really very important. Same thing with a database. So we've talked about blobs, buckets, containers. Again, it's not a Docker container in our context. It's the same as a bucket. It's where blobs are organized, stored, and it's that part of that hierarchy. All right, so what is this object besides being a blob? Well, again, not to be confused with what you would have in a database object or programming or other programmatic data structure. The object is a series, a stream of bytes. An object can be 0 bytes in size. An object could be 10 bytes in size. An object could be 1,000 or 1,000,000 bytes in size. Unlike regular file systems, files where your size is somewhat defined by the file system itself, i.e. you may have partially full files, but that granularity is determined by the file system, how things are organized, which file system you're using. Are you using NTFS, or are you using REFS or ext5 or XFS, whatever. With object, it's the object storage system that is managing those bytes, but you as the user of those objects or blobs have control over the size and how they get used. And again, part of that is keeping in context, what kind of a blob is it? Page blob, blob, append blob, which as their name kind of implies, append blob is you're just going to keep appending to a blob, good for logging sorts of applications. Now, here's the thing with objects, as I mentioned, it could be a stream of bytes. One of their characteristics, one of their attributes is that an object storage system typically can hold more objects, i.e. entities, than a normal file system can. So in other words, you could have more items in it. Likewise, the size of a object or blob, some will say it's infinite, but the reality is it's limited only by the architecture implementation of that particular system. In other words, there may be a upper limit that might just be what is currently supported. The gist of it is that you can have more objects, more blobs, more entities under a given unit, i.e. a bucket or a container, than you would or could under a traditional file system. And those entities, those blobs or objects, can also be larger than what you would normally have within a file system. The other attribute is that being how you have that dynamic, all that flexibility, is that whatever is using the object, whatever application, whatever tool, whatever utility, whatever file system, because a file system can sit in front of or on top of objects using the object as its back and store, is what defines how that data gets used, allocated, and formatted. There's an analogy here to a database where if you give a database storage, the database, particularly if it's using the storage as quote unquote raw, defines how the data is actually laid out, organized, and how the underlying storage is actually used and managed. Object storage is giving you that similar capability where it's the endpoint, that application, that utility, that tool is defining how that storage is being laid out, allocated, as opposed to a regular file system or even regular block access. Okay, we'll get more into this as we go. Another point of context term here is the endpoints, okay? An object, a blob, a bucket or container for that matter, is accessed via its endpoint. And that endpoint is usually a URL of some sort, some format that points to a particular blob, bucket, container, object, and that you could also specify with offsets depending on how that object or that blob is being defined and used. So it's that entry point that thus makes it easily accessible as opposed to a traditional address, which might be hard to remember or how to keep track of. Okay, so as I mentioned, there's different types of objects or blobs. There's append, there's block. A page blob is common in the Microsoft, in the Azure world, where a page blob is used for virtual hard drives, virtual disks, imaging, stuff like that, where a regular blob is more analogous to a object in the AWS world. Objects and blobs, they can be immutable. In other words, write once, read many. They can be hot, i.e. active. They could be warm, somewhat active. There's not a long delay. They could be cold. In other words, less frequently accessed, but your data can be accessed. It might just take you a little bit longer. Or it could be frozen. In other words, you get very, very low cost. It's not meant for accessing very frequently. When you go to reach or touch an object or a file that's in the object, it may take a while. That might be minutes or hours or longer for you to be able to access it. The objects can be stored on hard drives, solid state, whether it be NVMe, SAS, SATA. They could be stored even on tape, but that's all abstracted by the object storage system, object storage solution, or object storage service. And that could be on-prem, it could be in the cloud, in between. Okay, so S3, here's a context. S3 could be the AWS Simple Storage Service, aka S3. That's what the three S's stand for. Or it could also refer to an API that's generally de facto industry standard for accessing objects. So you got to keep that. When somebody says S3, are they referring to the actual service on Amazon or the API for accessing somebody else's objects via some other storage system or storage service or solution? So keeping context in mind and those different pieces that we just touched on, and let's move forward. Okay, so here's big picture, kind of visually looking at some things. Different applications have different workloads with different data requirements. You could say there's different kinds of data, just like there's different kinds of apps and workloads, whether they be virtual, containers, hypervisors, bare metals. And that with the different types of storage, we have object or blobs, there's file, and there's block that we know about. And the one I'm kind of off to the side on here, I didn't mention, would be table, which is database. But the database would typically be using one of those three, object, file, or block. Okay, the storage attributes, there's some commonality. You can do tiering, replication, archiving, use them for backup, different attributes, different characteristics. And those could be within the cloud, those could be on-prem. You could have storage system or storage software running on-prem that's actually tiering or staging data from that on-prem, on-site local storage to a cloud service, whether it be AWS, Azure, Google GCP, a long list of others. And ultimately, that cloud service, they might be using for their back-end object storage, they might be using solid state or drives or maybe even tape, but it's all abstracted from you. It's that object service that gives you that abstraction layer to do whatever it is that you need. And again, you've got the different tiers, categories, and classes. And I put a picture of the logo in my book there because I'm actually using a lot of excerpts from the different chapters of my book in the Software-Defined Data Infrastructure Essentials that goes into a lot more details, a lot more pictures and examples and things like that. But in the interest of time, let's keep rolling here. So this brings us to what is and what is not object storage. So as I mentioned before, objects and blobs are an entity, let's say a data structure, how storage is organized, of 0 or more bytes. It doesn't have to be on 512 byte boundaries or 4096 or whatever your allocation sizes are. It's variable. Some might say deja vu, boy, that sounds like what we had way, way long time ago with variable block and variable allocation. And yeah, there's similarities there. So for some, it might be deja vu. For others, it might be new and revolutionary. But the key is that variable in size, different tiers, categories, how they're organized. And you have this notion is that you can view all the objects under a bucket, all the blobs under a container. You can view them as a big flat namespace, or depending on how you choose to use them, they can also be organized and viewed in a hierarchical, kind of like a traditional directory structure, where you have containers under containers with blobs in them, or buckets under and then blobs organized or objects in different ways. So that's where you can have the buckets or containers containing more objects or blobs entities than in a traditional file system. And as I mentioned, the object storage, it's not exclusive to just being in the cloud. It can be on-prem, it can be back and forth. It could be a backing store for an on-prem storage system, storage software solution for doing things like backup, disaster recovery, and then tiering. So a lot of different options there. And again, how does object storage differ from regular storage? It's that larger namespace. It is that larger access that you can store more entities that they themselves can be larger. And again, that size, that flexibility, and just giving you that abstraction. And keeping in mind with the different types of objects or blobs, okay, and the service. And this is where price comes into play. You could have very, very fast, very, very high speed transfer rates for object, besides being highly scalable. You could have very high performance where you might be doing fast writes and then fast reads for recovery, or you can select different tiers, different categories for your different service needs. Okay, so why use object storage for disaster recovery? Okay, it can be lower cost depending on which tier, which category classes you're using. Another factor comes in is how much durability. This is what trips some people up. How much durability does the object storage have? Well, does that mean availability? Well, the thing is that availability is the sum of accessibility, can you get to it, and durability, how durable is it? How much resiliency does it have? How many failures can it tolerate? So you've got different options that when the bucket, when the storage service, the storage category, the storage class of how many nines of durability do you want? Could you have 15 nines? Yeah. Some services promote that. Some might say, well, it's impossible to have 15 nines of availability. Key context is the conversation about availability or durability, okay? So if you see 15 nines durability, don't assume that's 15 nines of availability. That's how durable, okay? That's how many faults can be tolerated, that resiliency aspect to it. So that's one of those options that those where the different buttons and levers come into play when you're choosing object storage is, what are you going to pick? One size fits all? Are you just going to go for the lowest cost? What's that performance attribute going to be? How is it going to impact you? So in other words, for backup and disaster recovery, that ability to have lots of objects or blobs, entities, so that you can have lots of snapshots, lots of copies, lots of things like that. But that can be of variable size, along with the metadata to support that rapid searching, indexing, tracking, and other management controls. And as I mentioned, those different attributes, including immutability, the ability to append, that different durability, the access, performance, encryption, and things like that. So it really allows the application, for example, a backup tool, a replication tool, a data protection tool, to define how the storage within those blobs, within those containers, within those objects is actually being used to optimize for their performance. And as I mentioned, it can be accessed natively via APIs or via gateways and file systems for compatibility. So there's a lot of different options, a lot of different capabilities. And one commonly referenced is that because it can be lower cost, depending which attributes you choose to use, it could also be a alternative to directly, key phrase I'm using there, directly using tape or other mediums for protection storage. Some of the services may have or do have tape in the background. It's abstracted. You probably wouldn't know it unless you did some digging, poking around. And that's the way it should be, is that it's abstracted from you to give you different service attributes. All right, so how do you access this object storage stuff? Well, via APIs like S3, you could issue gets, puts, lists, drs, other sorts of functionality, semantics, or via different tools, gateways, utilities, storage systems, and file systems. Some applications can speak natively to the different object storage. Some have to access via a file system. And then where they define the bucket, the ownership, the access control permissions. I've seen some services where you as the user don't have access to the bucket per se, that it's all done via a storage solution or a data protection solution. Others, you have control over that, and you can see the billing and other sorts of information tied to it. And likewise, which storage class or category performance, which are going to have that impact on your cost structure. The solutions will take care of that for you. Where that information is available, reviewable, but that the solution helps offload of that, including managing your keys to your buckets, your objects, your containers, and things like that. So pay attention to the default storage category, the service level, the cost of the storage, the performance as a part of cost. Don't look at just simply lowest cost. Real quickly, here's just a little block diagram that shows what could be a flat namespace, that the buckets, the containers that then have objects tied to them, and how an object has two actual pieces: the data from 0 to n number of bytes, along with that metadata, that attributes, the descriptors, and other information, including life cycle, replication, durability, and related things. Okay, so what about some tips and tricks around object storage as we start to wrap up here and go into some quick Q&A? Many cloud service object storage breaches have been the result of doors and windows, pun intended, left open, i.e., that the URL, that endpoint was left open to the world, that it was open for read, that there was no access controls, that you have the access, but you need credentials, even though you've got access to it. So that's something to keep in mind, that if you're going to have this bucket, if you're going to have this container and make the objects and the blobs viewable to the world, well, do you really want it to be viewable to the world, or that the world can access it, but only with authentication, only with the right credentials, the keys, signatures, and things like that? So it's something to keep in mind. Follow the service provider's best practices and tips to enhance your own best practices, along with those recommendations and tips of a storage service, a data protection tool, utility. Leverage their best practices. Also keep in mind, does your app or the tool manage your keys? Do you have to turn all your keys over? Do you have, what level of control do you have that to your keys, but also to all of your information, as well as who has access to those sorts of information, as well as understanding what your cloud service type, along with associated performance, the durability, and cost attributes are. As I mentioned before, there's a lot of scalability with object storage. There's a lot of cost capabilities, performance. You have to keep those all in perspective and look simply beyond that lowest cost per capacity. How is it going to be used? Is it going to be for a deep, cold archive? Is it going to be for backups that are written once and hopefully never retrieved? Or is it going to be used for data protection, backup recovery, where you're going to write the data, but that you may be accessing it on a more frequent basis than what you think? You want to keep all those in perspective when you're defining that those attributes for a bucket, as well as how can you go from one attribute, one class category to another. And there's different tools out there besides the different data protection and storage solutions, just a couple of which are mentioned here. All right, let's wrap up for now, and we'll move into some Q&A. Look beyond the lowest cost per capacity, which I've mentioned. Know how the storage will be accessed. Understand the access, durability, and availability classes and categories for that object storage, the different tiers, and so forth, which also means know your biz and your app requirements, the workload. The best solution is going to be the one that works for you. And with that, you can learn more at my website, StorageIO blog, my books, storageioblog.com/books. There's my Twitter, there's my email. And with that, Gladys, do we have time for some questions?
We have a good couple of minutes for questions, and I'm going to try to squeeze in a good couple of questions because we have a couple of really great ones for our audience. So let's start with Robert. Robert asks you, Greg, what are the associated costs of utilizing object storage for backup and disaster recovery?
Yeah, so there's a couple of key points there. There is the cost of the object storage, i.e., whether it's an on-prem, on-site solution, the hardware, the software that goes with that, or the service, i.e., AWS, Azure, GCP, go down a long list of others. So there is that cost of that storage service, and its recurring monthly cost, as well as the attributes. Are you going for high performance? Are you going for low performance, infrequent access? What are those performance characteristics? What are those durabilities? Do you want copies spread across multiple data center zones, availability zones? All those different attributes add up to the cost. But there's a couple of other pieces. Do you need any special plugins or tools or utilities to be able to use it? Does a data protection tool already come with that native capability where it can use it? What are the associated costs with that?
Great. From Barry, how does object storage ensure compliance with regulatory and compliance requirements for backup and disaster recovery?
Yeah, great question. Is that like any other storage, it's how you define it, how you use it. But having said that, is that with the different offerings, and this is where you got to look in and you got to go more than just check the box, is it object storage or not? No, you got to go deeper. Is what is the immutability capability? Do you have hard deletes, soft deletes? Can you set where hard deletes can't be done without particular authentication? Can you set up where the different access controls, the different policies around who can view what? How can you revoke the authentication and access controls to meet the different regulatory compliance needs?
Great. Let's see here from David, who asks, what is the scalability and performance of object storage in the context of backup and disaster recovery? And David's question is a two-parter, so I'll let you answer this part one first, Greg, and then I'll get to David's second question.
Okay. Short of the, no offense to the vendors, but short of the vendor common answer, which is unlimited or infinity, the real limit is what does that particular service, product, solution currently support, i.e., you go in there and it'll be a number of what is the maximum number of objects or blobs per bucket, and what is the maximum object size or blob size currently supported. And it's usually a very, very big number.
Right. And then so David follows up with, how does it handle large-scale data replication and recovery?
Handles it very, very well, and it can be done in a couple of ways. One is that some of the services, some of the products, some of the solutions actually have underlying ability to replicate an object or a blob from one availability zone or a data center to another. Tools that from different third-party, different solution providers also have that capability of being able to write a blob, write a object into different locations. So you've got different options depending on what solution services you're looking at.
Great stuff. We're going to roll right along to Alyssa's question. How can we integrate the use of AI with available systems in my company to ensure backup optimization?
Okay, there's a couple parts to that. Is what does your AI system need for storage? Does it need file-based access, or does it need block-based access, or can it speak a native object? Depending on what that is, those are some of the different discussions that how you're going to plug that in. In terms of the storage itself, the object storage would give you that ability to have bigger pools of storage with larger entities, those capabilities. But it really comes down to your apps, your environment, and how compatible and what do you need to have that compatibility between your environment, your apps, and the object storage.
Great question. And I'm sure you're going to get a lot more AI questions coming in the next couple of months, Greg. So
oh, absolutely.
Brace yourself. Let's see here. Chelsea asks, what are the specific security measures and protocols in place to protect data stored as it pertains to object storage and disaster recovery scenarios?
Yeah, so again, that comes back to if by default, what does the service have everything locked up, closed up, no access by default? You can go in and when you define that bucket or that container, you can define the attributes of anything that is going to come in underneath that, how they behave by default. What is their security? What is their authentication? how will those be able to be accessed by whom, when, and how? So part of that is what the provider or the solution has by default, and also what you set or go in there and enable or turn off by your configurations.
Okay, and then let's see here. Drew just wants a clarification. Is the backup on Amazon on Glacier Archive or just Glacier?
That should actually be Glacier, but no worries. So Glacier is a tier, it is a category, it is a class of where data, i.e. objects, can be stored. AWS has different tiers, hot, infrequent access, seldom access. Glacier is ice cold. Put it there and it may take a while for you to be able to get it back in exchange for a lower cost, assuming you're not accessing it very frequently or deleting it right away.
Great. Nicholas asks, are there any limitations or considerations to keep in mind in terms of versioning and retention of backup data? And how does object storage handle this?
Yeah, a great question. It's almost like reversing it, which is object storage lends itself to, you're going to create an entity, you're going to create a blob, you're going to create an object that is for this particular instance of a snapshot or of a backup, and then you're going to have another object for the next instance or version. So you can also enable versioning on objects, depending on the storage, solution, the service, the attributes. That can be one of the attributes, which is enabling versioning, which means that the version, the original one, stays intact. You've got a new version of it that can be kept and so forth, just like you would with a regular snapshot. So those are all capabilities. How you choose to define and use them is up to you or whoever's doing the work for you.
Great. Let's see, a couple more questions to go. Thanks, Greg, for hanging in with me here.
No worries.
Lynn asked, how is the data transfer speed? Object storage, while highly scalable, may have limitations in terms of the data transfer speed.
Yeah, so it's going to come back to, are you putting on the lowest cost object storage, which is going to have performance penalties, or are you going on to a higher tier? Likewise, are you going to put a transactional database on object storage? I wouldn't recommend it, versus putting that on more of a premium storage, whether it be an all solid state or something like that. You have to make those decisions. The performance transfer times for writing into objects can be very, very fast. If you're doing transactional, you want to look at a different class or category of storage, keep all of the attributes and service category classifications in perspective.
Great. And a final question from Jeremy. When will the disaster recovery space catch up with the SaaS landscape? The example he gives is being all in with Microsoft Azure, no hybrid, no on-premise. Where can companies find real disaster recovery tools that will protect your Azure spaces, like Azure File Storage, beyond OneDrive? There are so few options.
Yeah, I would take OneDrive out of the picture. There is part of your solution, pun intended, or, Anyway, Azure has quite a bit, and we don't want to dwell on that because it's not a focus on Azure, but there's a lot of capabilities there, just like there are in AWS. And I would actually say a lot of data protection solutions in general, they might be third party, have caught up with the SaaS and the PaaS landscapes, because many of them are PaaS and SaaS based, in addition to be able to be used on-prem.